Hello all, welcome back. Today we will discuss what telecommunications traffic is about. So in this telecommunication traffic, first let us deal with what telecommunication system is. So with respect to telecommunication system, it is nothing but a communication system in which communication happens between two places which are a large distance. So we know that in a telecommunication system also we need to obtain a desired throughput. Throughput basically deals with what amount of data being transferred from one end to the other end without any loss. So when we are dealing with a telecommunication system, traffic handled by the telecommunication system is also very important. So traffic to be handled must be considered. So this will determine the number of trunks to be provided. So we know depending upon the traffic that need to be handled by the communication system, we need to provide required number of trunks. If the traffic is large, we need to provide large number of trunks. If traffic is very small, then we can make use of small number of trunks to provide required throughput. So in a telecommunication engineering, we have to define so many terms like line, 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 trunk, and many other terms are used. So if I am dealing with line, 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 it is the connection between the subscriber and the exchange. So whatever the line that goes from telephone exchange to the end user, that is subscriber, so we call it as a line. Similarly, we also deal with trunk. So trunk is a connection between two exchanges. If I assume at one place we are having one exchange and we are having another exchange, so between these two exchanges, whatever the line that goes or whatever the network that goes between two exchanges can be said as trunk. So when we are dealing with teletraffic engineering, the term trunk is very used many times, and this will describe the any entity that will carry one call. It may be an international circuit. Please note that whatever I said with respect to trunk, exchange may be between one place to another place. Not only that, it can be a circuit between international exchanges also. And there exist thousands of kilometers from one exchange to another place, and some exist between a very few meters of wire is required with respect to trunk. So how we arrange these trunks, and we need to make use of some switches to connect whichever the line we want to have within the telephone exchange, and it is called trunking. The process of arranging trunks and switches in a telephone exchange is called as trunking. So if I consider a record in which within a particular time duration how the number of calls are progressed, we will have a staircase plot like this. So with respect to different duration or with respect to different time, so the number of calls in progress over a particular network or telephone network will be varying as shown in this figure E. So this is for short duration. Similarly, we can consider for long duration also. So when we are dealing with for a long duration over a particular day, so we can see during 10 a.m. to 11 a.m. so the traffic observed is very large. Similarly, as the time goes, so traffic will decrease, and again at certain duration at around 9 we will have a larger traffic, but the maximum traffic that we are achieving in this duration is called as busy hour, and generally this busy hour is defined for 1 hour duration. Is it clear? So it is very important to know during this busy hour what is the number of calls? The number of calls that are in progress, or the number of calls that can be handled by the telecommunication system. Okay, so this figure plots traffic carried or traffic variation during a particular day. So we know that the calls will initiate and end, and it is of a random manner. As we have seen over a particular day, same we can plot over a particular week also, as well as over a particular year also. If I am speaking with respect to a particular week, we observe larger number of calls during Sunday and Saturday. Similarly, with respect to a year, we may observe large number of calls during summer season. And please note that the number of trunks to be provided obviously depends on the traffic to be carried. So if the traffic is large, then the number of trunks required is also a very large in number. Moreover, the number must be sufficient for the busiest time of the day. So please note that the number of trunks required is completely dependent on during this busy hour, where the number of calls are maximum. A period of 1 hour is chosen which corresponds to the peak traffic load, and this is called the busy hour. As I mentioned, during 10 a.m. to 11 a.m. the busy hour is defined. Please note that the amount of equipment provided must be sufficient to cope with this busy hour. And you may observe that during other time the system is somewhat idle during most of the other day. So that is why we observe some telecommunication operating companies offering their customers cheaper calls at off-peak periods. Off-peak periods in the sense you may observe some telecommunication operators providing cheaper calls during night, that is from 11 a.m. to morning 6 a.m. So that was observed because during that time the number of calls that are in progress are almost very less, and we can make use of that particular duration to serve few users. So now let us define what is the unit of traffic. So the traffic intensity is more often called simply the traffic, and it is defined as the average number of calls in progress. So the number of calls that are in progress defines the traffic intensity of a particular telecommunication system or a telecommunication network. So generally we refer this traffic intensity as just as a traffic. Although this traffic is a dimensionless quantity, a name has been given to the unit of traffic, and that is given as Erlang, and it is just abbreviated as E. Generally we write capital E to represent Erlang. So it is named after A.K. Erlang, the Danish pioneer of traffic theory. On a group of trunks, the average number of calls in progress depends on both the number of calls which arrive and their duration. So the average number of calls in progress is nothing but a traffic that we have discussed before. So the traffic over a network is completely dependent on the number of calls arriving as well as their holding duration. The duration of a call is often called its holding time. So for what duration the call will be in progress is generally defined as holding time, because it holds a trunk for that particular duration. So let us consider one figure in which we are having an example of 1 year long of traffic carried on 3 different trunks. So we are having 3 different trunks, trunk 1, 2 and trunk number 3. So we are making 1 year long of traffic to be passed through these 3 different trunks. If only one trunk is involved in transmitting the entire 1 year long of traffic, then we can show in this figure. Similarly, this 1 year long of traffic is distributed over 2 different trunks. Similarly, we can distribute this 1 year long of traffic over 3 different trunks. So this empty in this particular trunk defines the free. It means the trunk is free, and if it is shown, it means that the trunk is busy over this time to this time. If I assume the time from here to here is 1 hour, then during that particular time the 1 year long of traffic is passed through the system. In North America, traffic is sometimes expressed in terms of hundreds of call seconds per hour. Generally we call it as CCS. Since we know 1 hour contains 3600 seconds, so 1 year long will be defined as 36 CCS. From the definition of the year long, the traffic carried by a group of trunks is given by A equals CH by T. So we know through trunks we are making some traffic to be passed through a group of trunks, and this year long has defined or provided a formula which defines the traffic expressed in year long. So traffic in year longs, A is equal to CH by T, where C defines the average number of calls arrivals during time T. You can assume this as number of calls arrivals during time duration capital T, and H is the average call holding time. What is the number of calls that are arriving over this particular duration, as well as for how many duration the calls are in progress is defined by H. So let us consider one scenario in which capital T is equal to H. Let us say we are having a traffic such a way that the total duration is about 1 hour and the number of calls arriving is about 10, and each 10 users are, or each 10 calls are holding for a duration of 1 hour. So then the traffic in year long will be exactly equal to C. So that is what I have shown here. Thus the traffic in year long is equal to the mean number of calls arriving during a period equal to the mean duration of the calls. If the holding time is exactly equal to the time period over which we are concentrating, so then observed traffic A will be equal to number of calls that are arriving over this particular duration. And please note that a single trunk cannot carry more than 1 year long of traffic. So generally A will be always less than or equal to 1. So as you have seen here, so a trunk, even though it is busy over complete duration, the maximum traffic that it can pass through is about 1 year long, not beyond this. So always please remember the traffic is always less than or equal to 1. And this traffic defines for what duration the trunk is busy. So traffic defines, the traffic is a fraction of an year long equal to the average proportion of time for which the trunk is busy. So if the trunk is busy for long duration, you can say that traffic is more, and if the trunk is busy for long duration or we can define the traffic as occupancy of the trunk. If the trunk is occupied in transmitting the signal for longer time, we can say this as occupancy. The probability of finding the trunk busy is equal to the proportion of time for which the trunk is busy. Thus, this probability equals the occupancy of the trunk. So we know that if the traffic is more, then the occupancy of the trunk is also more. So we will have clear correlation between occupancy and traffic. So we can sometimes we define occupancy of the trunk as L long, which is exactly equal to the traffic supported by the group of trunks. Let us solve one example in which they have said on average during the busy hour a company makes 120 outgoing calls of average duration 2 minutes. It receives 200 incoming calls of average duration 3 minutes. Find the outgoing traffic, incoming traffic as well as total traffic. So please note that this total traffic is the summation of outgoing traffic and incoming traffic. So during the busy hour, that is over a duration of 1 hour, a company is making 120 outgoing calls as well as it is receiving 200 incoming calls. They are given each calls are of about, so outgoing calls are about duration of 2 minutes, whereas incoming calls will stay for average duration of 3 minutes. So first let us calculate outgoing traffic. So the outgoing traffic is equal to, that is A is equal to CH by T, where C is the number of calls arriving over this particular duration, that is 60 minutes. So we are defining this as 60 minutes because they have given holding time in minutes. So A, we know that A is equal to CH by T. So this is CH and T. If we compute this, we will end up with 4 year long of traffic is involved with respect to outgoing traffic of a particular company during the busy hour. Similarly, we can calculate the incoming traffic during the busy hour also. So here also A is equal to CH by T, but here the holding time of incoming calls is about 3 minutes. You can calculate this to be 10 year long. So the total traffic will be equal to 4 year long plus 10 year long, which is obtained as 14 year long. And please note that on average 4 outgoing calls are made during this average holding time of 2 minutes. It means that if I consider a duration of 2 minutes, means if I make this T as 2 minutes, H is also 2 minutes outgoing calls. If T is also considered for 2 minutes, then traffic observed will be equal to number of calls arriving. So that is what we are defining here. On average 4 outgoing calls are made, so that will be exactly equal to traffic A. On average 4 outgoing calls are made during this average holding time. Similarly, if I make T as H, which is equal to 3 minutes, then I can have incoming calls during that particular duration 3 minutes, can have that to be equal to 10. So let us solve one more example in which they have defined that during the busy hour, on average, a customer with a single telephone line makes 3 calls and receives 3 calls. The average call duration is 2 minutes. What is the probability that a caller will find the line engaged? So finding the line engaged is nothing but occupancy. What is the occupancy that we are observing with respect to a particular line? So it is given that a customer is making 3 outgoing calls and he is also receiving 3 different calls. The call duration, average call duration is about 2 minutes, that is with respect to incoming as well as outgoing calls. So we need to find what is the occupancy of that particular line. So occupancy of line is equal to, that is, this is also equal to A, which is nothing but occupancy. We have already defined that occupancy is nothing but a traffic. A is equal to CH by T, where C is incoming calls plus outgoing calls. So total 3 plus 3 6 is the calls that are arriving this particular line. H is over 2 minutes we are dealing with. The average holding time is about 2 minutes within this particular duration over one period, that is over 1 hour will be dealing with. And if I calculate, the occupancy of line is obtained to be 0.2 L long. As I defined, traffic as well as occupancy of a line is defined in L long, or the unit is L long. Or I can say this is equal to probability of finding the line engaged. So probability of finding a particular line engaged is nothing but the occupancy of that particular line, is nothing but the traffic of that particular line. So now let us deal with another important topic called congestion. So what do you mean by a congestion? So when we are dealing with traffic, a situation can arise that all the trunks in a group of trunks are going to be busy, and so it can accept no further calls. So this state is known as congestion. So here we may arrive all 3 different trunks are busy over one particular duration. So if any fourth observer or fourth caller wants to make a call and we are supported with only 3 trunks, and right now I am saying that whatever we are having this shadow are also there with respect to this trunk as well as with respect to this trunk. So all 3 trunks are busy over the duration 1 hour, and suppose the fourth or the extra person wants to make a call, so he will observe the busy situation, or he will observe the congestion, because all other 3 persons are already in conversation with the other persons on the other side. And please note that a situation is arising where all the trunks in a group are busy, and generally we may observe this type of situation during busy hour only, because during other time we will be supported with good number of trunks, or the number of calls that are in progress are very less during other time, but number of calls are maximum during busy hour. So during that particular busy hour we are going to observe congestion. Please note that when I am talking with respect to congestion, congestion is observed because all the trunks are handling the calls. No one is free to accept new calls. So such scenario or such state is known as congestion. So when I am dealing with switch systems, there are 3 different types of switching systems are there: message switching system, circuit switching system, and the other one is packet switching system. We will deal with those systems in coming classes. So with respect to message switching systems, calls that arrive during congestion are made to wait in a queue until an outgoing trunk is made free or becoming free. So thus they are delayed but not lost. Not lost because those calls or those data or those messages are placed in queue where they want to or they need to wait for certain duration until the trunk becomes free. So such systems are therefore called queuing systems. So where queues are involved, where memory is involved, we call such systems or message switching systems as queuing systems, or also called as delay system, because delay is involved in such systems. We are having one more circuit or other type of systems we call it a circuit switch system. So in these systems, a best example is telephone exchange or telephone line. So in telephone exchange, all attempts to make call over a congestion or over a congested group of trunks are unsuccessful. So if congestion is observed in a telephone exchange, so if you make any attempt to make calls, such calls will be dropped. We don't observe any success over those calls. So such systems are therefore called lost call systems. Because calls are going to lost, because all trunks are busy in handling the incoming calls, or already some calls are already in progress. No additional calls are accepted. Such systems are called as lost call systems. In a lost call system, the result of congestion is that the traffic actually carried is less than the traffic offered to the system. So whenever the traffic offered is more than the traffic carried by a system, we observe congestion, right? So we can have an equation for traffic carried, and it is given by traffic carried is given by traffic offered minus traffic lost, or you can say traffic offered will be equal to traffic carried plus traffic lost. You can take this to LHS. So it is clear that traffic offered also depends on the scenario congestion. If the traffic offered is more than the traffic that can be carried by a system, we will observe congestion or we will observe traffic loss. So this traffic loss should be minimized. So the proportion of calls that is lost or delayed due to congestion is a measure of the service provided. If the service provided is good, then the number of calls that are lost or delayed will be less in number, right? So this gives rise to a term called grade of service. This is very important. Grade of service is a term that defines how efficient the traffic is handled by the system. So in a good telecommunication system, the grade of service, if the grade of service is good, then the calls that are lost will be very less in number. So for a lost call system, the grade of service, generally we define this grade of service as B. Grade of service B may be defined as the ratio of number of calls lost to the number of calls offered. So grade of service is the ratio of number of calls lost to the number of calls offered as defined by this equation. So by this equation it is clear that the number of calls lost should be as small as possible. So by this equation it is also clear that this B should be as small as possible for a good switching system. So the number of calls that are lost should be much smaller compared to the number of calls offered. We can also give another expression for grade of service as traffic lost with respect to traffic offered. Of course, both are similar type of equations. So this grade of service defines the proportion of the time for which congestion exists. So if grade of service is very small, then the duration where congestion exists is also very small. If the grade of service is large in number, that means if the traffic lost is large in number, we will observe congestion for longer duration, right? So this grade of service also defines the probability of congestion, also probability that a call will be lost due to congestion. Grade of service is dependent on what the number of calls that are lost due to congestion. So by this equation, thus if a traffic A long is offered to a group of trunk having a grade of service B, the traffic lost will be AB. If the traffic offered to a system is A, capital A, then with a grade of service B by the system, then the traffic lost can be defined as A into B. Traffic lost is AB, and the traffic carried will be equal to A minus AB. Traffic carried. So traffic carried will be traffic offered, which is A, minus traffic lost, which is AB. A minus AB, taking A common, can write it as A into 1 minus B long. So this is what the traffic carried by the system, that is telecommunication system, is A minus AB long. And traffic lost in the telecommunication system is defined as AB, where A is offered traffic and B is grade of service of that particular system, and this grade of service is defined as the ratio of traffic lost to traffic offered, or the number of call lost to number of calls offered. So it is clear that the larger the grade of service, the worse is the service given by the telecommunication network, by the telecommunication system. So as you can see here, if larger and larger number of traffic are lost, then grade of service will be more in value. The value of the grade of service will be more. And please note that the grade of service is normally specified for the traffic at the busy hour. So we know during busy hour traffic is more. When the traffic is more at that particular duration, we will define grade of service for a particular telecommunication network. Okay. So let us consider a scenario in which during a busy hour grade of service can vary from say 1 in 1000 for cheap trunks. So let us assume a trunk is placed, or we are dealing with calls that are being made inside a particular state. So for calls that are made inside a state, we will have good grade of service. Good grade of service in the sense traffic lost is 1 over 1000 number of calls attempted. So it is given that during a busy hour the grade of service is 1 by 1000. So one call is lost during 1 hour out of 1000 calls. So generally when we are making calls inside a particular state, the call rates are cheap. Similarly, we will have another scenario where the calls are made between different state, one state to another state. Inter-exchange connections are involved. So in such case, the grade of service provided by the network may increase, and that is about 1 in 100. So out of 100 calls that are going from one state to another, so one call may be observing congestion. Similarly, if you are making expensive international calls where international routing is involved. So you can have larger grade of service. So grade of service 1 in 10. So 1 by 10 can be supported. So generally the number of calls that are going with respect to international calls are less in number. So in such scenario we can have larger value of grade of service. But when you are making larger number of calls, in that scenario you have to provide smaller and smaller level of grade of service. So smaller the value of grade of service will have better the system works. Please note that the basic problem of determining the size of the telecommunication systems is nothing but dimensioning. So what should be the number of, or what should be the grade of service that we have to provide for a particular telecommunication system is decided by the process called dimensioning. And it is a problem. Let us consider a scenario where it is given that the offered traffic is A year long and the specified grade of service is B, and we need to find what is the number of trunks, capital N, that is required. So generally number of trunks is defined as N, capital N. So we can calculate with given offered traffic A and the specified grade of service B, we can find what should be the number of trunks that I have to provide in order to deliver required level of grade of service. If the number of trunks are small in number, where the offer traffic is more, then the grade of service will be becoming larger and larger. So we need to make this grade of service as small as possible by providing larger number of trunks with respect to required traffic that need to be processed. So let us consider one more example in which during the busy hour 1200 calls were offered to a group of trunks and 6 calls were lost. So it is directly given grade of service B is number of calls lost, that is 6 to with respect to 1200. So 6 by 1200 gives grade of service. So they have also asked us to calculate the grade of service. So the average call duration was 3 minutes. Holding time H is 3 minutes. So we need to find the traffic offered, the traffic carried by the system, the traffic lost, observed, and the grade of service. So grade of service B is equal to 6 by 1200. So first let us calculate the traffic offered, and also they have asked us to calculate the total duration of the period of congestion. So for what duration congestion is observed with respect to this scenario. So the traffic offered A is given by CH by T, where C is the number of calls that are arriving, that is 1200. For holding time H is 3, and for busy hour for one duration, busy hour is for 1 hour, so that is 60 minutes. So we are writing here 60 because they are given minutes, holding time in minutes. If they have given holding time in seconds, then you might have written 3600 seconds in place of T. So the observed value is 60 year long. So 60 year long is the traffic offered. And coming to the traffic carried by the system, please note that the traffic carried is equal to what? Traffic offered minus traffic lost, right? So right now the traffic carried is out of 1606 are lost. So total remaining calls that are in progress is 1200 minus 6, that times holding time. So same equation, traffic carried is A equal to CH by T, where here C is the number of calls that are in progress. Traffic carried is number of calls that are in progress, excluding these calls that are lost. So the obtained value is 59.7 long. This is what the traffic carried, and we can easily calculate traffic lost will be equal to traffic offered minus traffic carried. Traffic lost is, or you can calculate traffic lost using the other equation also. Traffic lost is equal to CH by T. So where traffic lost is 6 calls are lost, and those calls were of duration. Of course, average call duration was given as 3 minutes to 60, and it is obtained as 0.3 error long. And grade of service is 6 by 1200 as previously defined. So you may observe here, if the number of calls that are lost is smaller and smaller, you will have grade of service to be smaller value. It means that if this is small, the better the system is. And also they have asked us to calculate the total duration of the period of congestion. So congestion basically deals with total duration of the period of congestion is equal to grade of service into total duration, that is busy hour. So congestion is directly dependent on grade of service. Grade of service multiplied with capital T gives the period of congestion. So and it was observed as 18 seconds. So it means that over one duration over this busy hour, if you are making these many number of calls and these number of calls are lost and these calls are of holding time of 3 minutes, then we will observe a grade of service of about 0.005 and we will observe congestion of about 18 seconds. We will discuss more about traffic measurement in our coming classes. Thank you.